Welcome to Chemistry with Mr. Brazil. Today you're going to learn how to determine molar mass, other words, molecular weight, and percent composition. So, what is the molar mass? Molecular weight, that's the old term, MW, and the percent composition of ammonium carbonate. Well, first let's talk about ammonium carbonate. You see the parentheses? Well, that parentheses is no different than in math. What we're going to do is that 2 is going to distribute. It's going to be 2 times 4, which is going to be 8 hydrogens, and 2 times 1, so 2 nitrogens. This 2 does not affect the carbon, nor the 3 that's on the hydrogen. So there's only 1 carbon, and there are 3 oxygens, okay? That 2 does not affect the 3, nor does the 3 affect the carbon. A lot of students like to think of that way. So that's not how that all works. So treat the parenthesis just like in math. It multiplies whatever's inside the quantity. Now, for molecular weight, what we do is we write down, and right now this is the long-handed method, which suits and fits right into percent composition. So what you need to do is you write each atom out. Eventually you're just going to do this on the calculator because you're going to be doing multi-step dimensional analysis and you can't be writing all this out all the time. But for now, let's do it. So we have 2 nitrogen atoms. You go to the periodic table. The atomic mass for nitrogen is 14. So that 14 now is grams per mole. So 1 mole of nitrogen is 14 grams. I'm going to put N. We multiply this, so it's going to be 28 grams per mole. N. Now let's get our hydrogen. So it's 2 times 4. There's where the 8 comes from. So there we have 8. And the atomic mass is 1.0079, so just 1 gram. So I'm rounding. Hydrogen, I'm going to put mole, okay, and that's just 8 grams per mole hydrogen. Now let's take the carbon. There's only 1, so 12 grams carbon per mole. So in this case, this is just 12 grams per mole. And yes, this will end up being tedious if you were to do this all the time with dimensional analysis. You just should be inputting this on a calculator. But for now, we're going to write it all out, which this is going to fit very nicely again to percent composition. So let's write our oxygen. There's 3 of them. And since it's 15.9994, just make it 16. So 16 grams per mole oxygen. Okay. And that will be 48 grams per mole oxygen. We add these all up, okay? And when you do, this is going to be 96 grams per mole ammonium carbonate. Okay, so this is the molecular weight, or molar mass is the proper term, because weight is a force, but that's how things go. But here's the beauty of writing this all out. We can also now do percent composition. And so here's the deal. Percent, if you remember, the equation for percent, which I want everybody to know, is part over the whole, or the total value, times 100%. You need to put the percent. That is a unit, which allows us to get the percentage. Okay, so here's the beauty. These values that we did for nitrogen, hydrogen, and carbon, and oxygen are the parts. The total is the whole. So to write this and properly write it, and write this out this way, you're going to go percent nitrogen equals 28, and I'm going to put units so that we know what the heck we're doing here. So nitrogen, I'm just going to take the whole, the 96 grams per mole, and yes, the units do cancel out, but we want to keep the nitrogen, times 100%. Okay, and that's going to give us 29.2% nitrogen. Okay, now let's do the same thing for hydrogen. Percent hydrogen, okay, 8 grams per mole. Divide by 96 grams per mole. And this is hydrogen, H, okay, parenthesis, and let's see, 100% and 8.3% hydrogen. Let's do our carbon. Okay, that'll be 12 grams. And yes, I'm writing this out because I'm trying to make sure that you understand quite clearly that these numbers are coming from the molar mass. And again, the units do cancel, but be patient because you're a beginner. You probably are learning this for the first time. So times 100%. Okay, and that's going to give us 12.5% carbon. And then for oxygen, we're going to take, oops, that was too big. So 48 grams per mole over 96 grams per mole. I'm going to fix something up a little bit here, times 100%. So let's fix this up a little bit. Okay. This was oxygen, that lines up better. And so our oxygen is 50.50% oxygen. Okay, this should all add up to 100, and it does. It adds up to 100%. Okay, now we know the percentages. This will become a valuable tool later for empirical formula. So that's coming up next. So keep studying chemistry. There's some other videos you can watch. So prepare questions for your teacher. Have a great day and a great evening. Bye.